Hello, my dear students and the rest of the learners. Welcome to part 18 of a 41-part series of tutorials in Fundamentals of Object-Oriented Programming in Java. In this tutorial, we are going to be looking at Java nested else-if selection structure. My name is MemJM, or you can simply call me Emily Swap. When we speak about nested if-else control structure, we are simply speaking about creating a structure inside another structure. This is because it is possible to embed one or more if-else statements inside another if-else statement or inside another structure. But generally, when we speak about nested if-else statements, we are simply saying that you can embed other if-else statements within an if-else statement, thereby creating what we call a nested control structure. The modular structure is used when you want to select one and only one option from several alternatives. In other words, my dear students and the rest of the learners, in real-life situations, you may have several alternatives to take, but only one activity or one alternative will be taken at any given time and not more than one alternative. And therefore, if you have a situation where you have several alternatives that can be taken or several alternatives available, from where you need to choose only one alternative to execute, then we use what we call a nested if-else statements. That's why we call this a modular structure. And for this reason, a modular structure is used when you want to select one and only one option from several alternatives. The modular structure has a single entry point, and that only one multiple alternative of the several possible alternatives is executed. Its syntax is as follows. If condition one, in other words, if a condition evaluates to true, then execute statement one. Otherwise, if the condition evaluates, or if condition two evaluates to true, then execute statement two. Otherwise, if condition three is true, execute statement three. Otherwise, if none of those statements are true, if the three conditions do not evaluate to true or none of them evaluates to true, execute statement four. In other words, my dear students and the rest of the learners, what this structure simply means is that you have several conditions to check. If the first condition is met, you execute statement one. If that condition is not met, you check another second condition. If that condition evaluates to true, you execute statement two. Otherwise, if condition statement one, if first condition does not evaluate to true, second condition does not evaluate to true, then you check condition three. If condition three evaluates to true, you execute statement three. Otherwise, if none of those alternatives evaluate to true, neither one, nor two, nor three, you execute statement number four. And therefore, the flowchart extract for such a structure is as follows. As you can see, my dear students and the rest of the learners, there is a clear indication of what happens. But first of all, the compiler begins by checking condition one. If condition one evaluates to true, then instruction one is executed. Otherwise, if it does not evaluate to true, that means it evaluates to false, the compiler has to check condition two, so that if the value of condition two is true, or the results of condition two are true, then the compiler executes instruction two. Otherwise, if condition two also does not evaluate to true, then the compiler checks condition three to see whether it will evaluate to true. If it's evaluated to true, instruction three is executed. Otherwise, If condition 3 also does not evaluate to true, then instruction 4 is executed and that section is completed and the compiler moves to the next statement after the structure. For example, if, for example, you have a value entered in memory location called sum, you have a value. So the first thing that happens is the compiler or the translator will check if the value in the memory location called sum is less than or equals to 0. If that value is less than or equals to 0, then the statement that is displayed on the screen will be the trainee is not yet competent, and the compiler will exit the structure. Otherwise, if I repeat this statement here so that we get it well, I have said, if the value in the memory location called sum is less than or equals to 0, then the compiler or the translator will display the message that the trainee is not yet competent. Otherwise, if the value in the memory location called sum is not less than or equals to 0, the compiler will check or the translator will check next. It will check if that value is greater than 0 and it is less than 200, meaning it is within the range of 0 to 199. So if that condition evaluates to true, then the system will display the message that the trainee is not yet competent. Otherwise, if the second condition is also not true, it does not evaluate true, the translator will check the third condition. And what is the third condition? The third condition is checking whether the value in the memory location called sum is greater than or equals to 200 and it is less than 300. So that is the range, 200 to a value below 300. If that value in memory location called sum is found to be within that range, then the compiler displays the message that the trainee is fairly competent. Otherwise, if that condition also, if this condition also does not evaluate to true, yet also this second one didn't evaluate to true, and the first one didn't evaluate to true, then what will happen is that the translator will display the message that the trainee is fully competent, and the check will be over. And therefore, the following is a program that prompts the user for 4 scores, computes the total, and determines the level of competence for the trainee. So this is a sample program. The comment is that this program computes sum of 4 scores, computes sum, and determines trainee's level of competence. The name of the package is total block structure. And then we have the statement which tells the compiler to use the scanner class from the package. It is import java.util.scanner. Now, just as a reminder, my dear students and the rest of the learners, is any time that you know that you are going to make use of an input, or you are going to make use of input device like keyboard, or you are going to read a value from the keyboard, it's always important that you include this statement within your program. And then from there, we have the name of our public class being total block structure, whose definition is a method called main, public static void main. Under it, we have local variables. We have 5 local variables, which are sum, EP, months, literacy, and programming, and they are all of type integer. And then from there, we define the statement, or we define an object called input. Now, this input is of type scanner. It is used for the purposes of reading. So we are supposed to read our value through input objects. And therefore, the next statement is to prompt the user to enter the mark attained by the trainee in programming unit. Once that value is keyed in, it will be read by the function or by the method next int through the object called input, and the value received will be stored in the memory location called programming. From there, the next statement to be displayed is enter the mark attained by the trainee in digital literacy unit. The value will be read through the method called next int, but that will be done through the object input. And the value received will be stored in the memory location called literacy. The next statement to be displayed is enter the mark attained by the trainee in months. It will be read, of course, through the object called input by the function called next int, and the value which will be received will be stored in the memory location called a months. From there, the translator will display the message, enter the mark attained by the trainee in entrepreneurship unit. Then the value will be read through the object called input unit by the function called or by the method called next int, and that value will be stored in memory location called EP. Once that has been done, we have read our 4 values. The next activity to be done is to compute the sum. So the compiler will pick the value in the memory location called EP and the content in the memory location called months, then add that to the content in the memory location called literacy, and lastly, add the content in the memory location called programming, and the overall result will be assigned or stored in the memory location called sum. From there, the next statement is to request the compiler or the translator to display the message on the screen that the total score for this trainee is pick the value in memory location called sum, followed by the ones out of 100 marks. So if, for example, the result for adding programming, literacy, months, and the EP results, for example, to 100, and that 100 is what has been stored in memory location called the sum, then the statement, the total score for this trainee is, will be as follows. The total score for this trainee is 100 out of 400 marks. And then write a new line. Next is to check if the value in memory location called the sum is less than 100. If the content in memory location called sum is less than 100, then the program will display or the translator will display the message, the trainee is not yet competent on the screen, and move 1 new line below. Then it will check if the value in memory location called sum is not less than 100, the translator will move on and check the next condition. Is this value that has been stored in memory location called sum greater than or equals to 100, and that value is at the same time less than 200? If that condition is true, the compiler or the translator will display the message, the trainee is fairly competent, and move 1 line below. Next, if the second condition is also not met, the translator will move on and check the third condition. It will check if the value in the memory location called sum is greater than or equals to 200, and it is less than 300. If that is found to be true, if the value is within that range, the translator will display the message that the trainee is proficiently competent. Otherwise, if that is also not met, if that condition is not true, the translator will move on and check the next condition, the fourth one. It will try to find out whether the value in the memory location called sum is greater than or equals to 100 or 300. And at the same time, that value is less than 400. In other words, it will check if the value that is stored in memory location called sum is within the range 300 to a value below 400. For example, 399.99. If that is true, the compiler or the translator will display the message, the trainee is fully competent, and move 1 line below. Otherwise, if none of those conditions are met, the compiler will simply display the message that the marks entered are not realistic, and move one line below. And that will be the end of the program. So how can we write that in Java IDE? So let's check how this program will behave if we code it in the Java IDE and also through Eclipse IDE. Remember, the name of our package and the name of our program will be total block structure. Total block structure. So let's proceed and do the coding. So we are going to start our program, load our IDE, which is Eclipse. Remember, if you're using any other type like NetBeans, the procedure is the same. You just need to load your NetBeans or your Eclipse and then wait for it to load. So we are waiting for hours to load. There we are. Once your IDE or once your IDE program like Eclipse has been loaded, you can click on File menu, point on New, and then click on Java Project. So New Java Project. And then you can give it a name. Let's call it Total Block Structure. That's the name of our project. And then click on Finish. From there, you create a file within your project. So our project is called Total Block Structure. So you right click on it, point on the new, and then this time around, you click on class. Once you're here, you give your Java class a name. So the name of one Java class will still be Total Block Structure. Total Block Structure. And of course, the modifier is public. And then you can pick or tick the method stubs you would like to create. And because every program in Java has the main function or the main method, which is public static void main string or main, it's good to check it. And once you have done that, you click on Finish. So here we are. This is our stub. A few statements have been added to our program. So what we need to do is to include the very first statement, which is import, because you're going to make use of the keyboard. So it is import java.util.scanner. Then semicolon. Once you are there, you can then define, you can equal the definition for the main method. You can also indent it nicely. So our instructions will be kept in between this opening brace and this one for the main method. Now, as usual, you can type your set of instructions here, one after the other, but it's always advisable that you write your program, for example, in a 1D processor, run it from there, and then once you are comfortable, you can transfer that code to the IDE. So, or you can just type directly. Otherwise, it's always advisable. Write your program on a piece of paper, run it from there, type it in a 1D processor, check it manually, and then key in or transfer or copy and paste that program in an IDE. So in our case, I'm just going to paste my program in this IDE because I've already typed it in a 1D processor. So I'll click here, right click my mouse, and just paste my program. This is the program that I've already explained. Always indent it nicely, as you have said, so that your program becomes easier to read and also easier to debug. So that's my program. I'm indenting it so that it is presentable and easy to debug. Then push this brace where it belongs. And of course, check if they are matching. Also, indent the other one nicely. So this brace is for this one. There's also this other one here. So there we go. And then we can remove any other characters that we don't want or that we don't need. Once you've done that, save your program. So this is our code. We can then run it. You can see that our program does not have any errors and it has executed. That's why it is asking us to enter the mark attained by the trainee in programming the unit. So if, for example, we type 23, you press enter, it asks you, enter mark attained by the trainee in digital literacy. We can type 34. Next, as you press enter, next is enter the mark attained by the trainee in months. We type, for example, 90, and you press enter. Next is enter the mark attained by the trainee in entrepreneurship. So we can key in, for example, 55. You can see that the statements are being executed in the order of listing here. Once you have done that, next is once you press enter, we expect that the computation will be done and the score will be displayed here in this statement. And then we are going to have the program also proceed and check or execute one of these statements based on what the result will be. We are going to have the respective statement displayed on the screen. So let's press enter and see. You can see the total score for this trainee is, so the translator or the compiler, or in other words, the processor, has already been able to compute the sum of the values entered, and the sum is 202. So it is going to display, or it has displayed, that the total score for this trainee is 202 out of 100 marks. And lastly, it is displaying that the trainee is proficiently competent. So let's see, where does 202 fall? Is 202 less than 100? No. So this cannot be displayed. Is 202 greater than 100? Yes. But is it less than 200? No. That cannot be done. This statement cannot be displayed. Is 202 greater than or equals to 200? Yes. Is it less than 300? Yes. So that's why you can see, my dear students, that this is the statement that has been displayed, that the trainee is proficiently competent. Otherwise, once that has been done, these other bits have been skipped or be skipped or be skipped. And once you have done that, you can now save your program. It's already saved. You click on close or editors, and then you can exit from the program, or you can exit from the IDE. And with that, my dear students and the rest of the learners, we have come to the end of part 18 of the series. You can now proceed and listen as well as watch part 19 of the series, in which you are going to learn about Java switch control structure. So congratulations for learning part 18 of part 1 on Java nested else if selection structure in fundamentals of object-oriented programming using Java. You can access the rest of the parts in the series, as well as other computer ICT videos, by clicking or tapping on the Meliswap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com, gmail.com. Thank you very much for listening to me. Let's meet in part 19 of the series, and God bless.